Hello, I'm Mohammad Dehghani. I'm going to talk about stopwords. As you know, one of the tasks in natural language processing is text preprocessing or text normalization. These day researchers attempt to reduce the size of text data because of two reasons. The first one, the extensive amount of text information available on the internet and the need to analyze it. And the second one, companies' hardware and financial concentrates. Text data in natural language processing and information retrieval contains a large number of words that don't contain much content. Again, it's their high frequency. It can be very useful to make a list of stop words that can be used to minimize text size. And now, an important question. What are the stop words? We are looking for a definition. Stop words are words with very high frequency and little meaning in a language, which help to form sentences but do not add any content. The following are typical examples of stop words to remove: conjunctions, prepositions, and pronouns. For researchers in the field of NLP and information retrieval, as well as business owners who are tasked with analyzing information on the internet, creating a list of stop words is invaluable. It is possible, for example, to remove a stop word from official text such as news or papers. It is helpful for researchers in the field of NLP to have a Persian list that is free, easy to use, and useful for pre-processing text data. There are two general categories of research on identifying stop words: non-automatic detection and automatic detection. A non-automatic method is to collect high frequency words and have an expert specify if the words are stop words or not. We should be understanding that it is impossible to analyze every text using lists collected using non-automated methods. You may find that a text containing economic concept has a specific stop words that do not show up in common lists. And about automatic methods, they use machine learning or deep learning algorithms to identify and collect stop words. In this article, we describe a semi-automatic method for generating Persian language stop words, later be used in NLP. Based on the text subject, this algorithm can present a stop word of each text. It is the use of word vectors and word embedding that makes this method different from other research. With the help of word embedding, the meaning of words can be represented and stored in a small vector in order to ensure that their synonyms have similar values. Traditionally, word embedding was based on a statistical method. Modern deep learning methods, like the word-to-vec method, have showed the ability to extract semantic similarity between words. The embeddings stores the semantic information of words into a vector, and the neighbors of the word are usually synonyms. So, an embedding of a stop word should also be regarded as a stop word. During this research, we used the FastText language model. FastText is a free language model that lets you represent text in a different ways. 157 languages can be represented using this language model. After converting text to vectors and for calculating the distances between vectors, we have to use similarity method. Similarity is measured by using the cosine similarity in the research, which means the inner product space is used to calculate the similarity between two vectors. Using this formula, you can calculate the cosine of an angle between two vectors and specify if they are parallel or not. In method section, first let's explain the process of data collection. The research data are collected from the text of the Young Journalist Club website and then normalized with the Parseval tool. As we can see, number of documents in each of the corpus topics in this table. Normalization includes these steps. The first one is deleting non-Persian words. And I need to mention that the selected topics are sports, sport, politics, economy, social media, science and health, culture and art, and society. We use IDF to rank the words. IDF is inverse document frequency, the statistical criterion that is used to measure the frequency of the words, and an 800 minimum frequency limit is used to select the words. By applying this criterion and frequency limit, 38 tokens are obtained. This formula involves the following. T stands for the term, D stands for the document, D capital stands for the total number of documents in the corpus, and N capital stands for the total number of documents in the corpus. Also, the phrase the element of D capital, T element of D refers to number of documents in which the term T has appeared. So, the smaller the IDF number, the more common the term is in the corpus. As shown in this table, each corpus term is ranked by a IDF weight in ascending order. As a result, experts review the list and tagged 313 items as a stopword, which did not add content to the text. The method proposed by the author of this article can be applied to different texts and topics, but in a present study we choose to include only the most common stopwords from different topics and texts. Because of this, some words which were not stopword at all, such as باشگاه or خبرنگاران, were removed from the candidate. Experts identified stopwords, and each stopword was then transformed into a vector by word embeddings and the FastText and GenSim library. Similar terms were obtained based on cosine similarity. An algorithm was defined and the machine was given 313 previous stopwords as an input in the form of the initial list. By applying the above algorithm, 5 nearest neighbors were selected and added to the final list for each stopword. The steps of the algorithm are creating an empty list called final list, and then selecting a term from the initial list, and in phase 2 adding the most similar terms to the selected term of the previous step in word embeddings to the final list, and then selecting the next term from the initial list and go to step 2, and in fourth step repeating steps 1 to 3 until the last term of initial list, and in final step removing duplicated terms from the final list. In evaluation section, the outputs were ready. It was then reviewed by experts to identify non-stopword neighbors, which were based on the algorithm output, a table of 313 rows and 5 columns. This table shows some of the results of this analysis. we can see the neighbors of each stop word. And then we discovered 10-14 stop words when we added the neighbors to our initial list. This equation was used to evaluate the percentage of precision in stop word detection. As we can see, TP is the number of true positives and Fn is the number of false negatives. The precision of the method was determined by calculating the precision for each column. In this table, you can see how precise stop word detection is. This table. And for compare our result and output with the other paper and research, we have two measures: the accuracy of the cosine similarity and the accuracy of the Euclidean distance of the terms. As a result, the accuracy of this method is closer to that of similar research projects on Turkish and English, and it is better than the study of Turkish language. This table shows that the model is very efficient in identifying stop words, as it considers semantic similarity instead of following traditional methods that commonly use backup words. And the two advantages of this approach are that it uses little memory and it analyzes each word directly. In addition, the model provides a way to identify verbal stop words. Thank you for your time.